So today we'll be talking about materials, and make sure you have the project where you have all the starter content. Go to your content browser and make sure you have the starter content folder here, which you can add by going to, if you don't have it, go to add and then add feature or content pack, and then go to content and then starter content. But I think most of you should have it, because I think all of you should have it because we used it before, right, last time. If you don't and you forget how to add it, just raise your hand and Ziwan can help you. We won't waste too much time on this. Make sure you have this, and then let's actually go to, and you can open new map or use the one from last time. We will be creating our first material, and as you may have seen, like the cubes that we brought in from the Unreal Engine, by like the default cube, when we add and go to basic, and for example, go to shapes and then cube, right? We have a default cube, and it just looks like a plain white surface. But these, for example, chairs and tables, right? We brought in from the starter content folder. They have this basic, like this realistic color, like wood color and texture applied to it, and also this cushion, right? This chair has some sort of material on its surface that makes it look like it has some sort of texture, right? Or roughness or whatever, like fabric feeling on the surface. So this is the importance of texture. Is the material is how it control the look of an object, because with this cube, it could actually be anything, change into anything if we add the materials to it. And even with this default cube, it already actually has a very simple basic material applied to it. So if we select this cube or any other shapes in your level, and you scroll down a little bit on the details panel, somewhere here you should be able to see a tag called materials right here, and this is the material slot for this object, for this 3D object, and we can see that it has currently has one slot, element 0. It has one slot, and this slot contained a basic shape material. So if we, for example, just click on this menu and we change it to any other things, like some other things in this list, we see that the surface material updates, right? And it turns into something else like this. We can just try a few things and see, how just by changing the surface material, it turns this very simple cube into something that looks completely different, right? So this one looks like a piece of stone being cut out from a wall, right? And you can try some other things. So this is what we will be learning today. We will create basic materials and understand most of its properties, and what properties each we can control. Okay, so let's open our content drawer and right click. Let's create a new folder called materials. So we organize our assets, put all the materials that we created into this folder. So we double click and open the folder, and then we right click again, and this time we have this creation menu. We should be able to see material. So you can see under the basic assets, it has the most commonly used one. Material is one of them. So let's create a new material and rename it M for material, and then underscore, maybe let's just name it test. So we just test what it does. Okay. So now let's maybe Control S to save it. Now this is a basic material, and if we double click to open it, we see that now we have a new graphed window, which looks a little bit similar to the blueprint, the blueprint editor that we've seen before with this node graph. So this is also a node-based editing, editing sort of system, a node-based editing system where we connect different nodes to create more and more complex and advanced functionalities to control the surface look of each of these materials. And if we zoom in a little bit, we see this basic node that has been created by default for us. It's basically like a list of all the basic properties of a material. So let's start our editing. So first of all, maybe we have a base color, which is one of the most, of course, the fundamental properties of any object. We have the surface color, right? And it's like the main color that controls the look of the surface. And you can sort of just like the blueprint editor, you can drag these wires out. And if you understand or have used other sort of image-based software, you may have know that color, mostly in the digital system, is controlled by 3 numbers, right? RGB values. So it's this red, green, and blue values. It's the same in Unreal Engine. So we have 3 numbers to control the color. Sometimes 4 if we add this sort of transparency into consideration, then we will have 4 numbers. Usually, if we're just talking about basic colors, then we have 3 numbers. So we can right-click and we can search for vector, but it's a little bit sort of complicated to search. But I just wanted to show you what it is. We will be using a constant 3 vector. If you scroll up all the way up to the list, you'll see that constant 3 vector. However, we have a very common, we have a very convenient shortcuts for it, because this is one of the most commonly used node in this material graph. So we just press the number 3 on your keyboard, 3, because it's 3 colors. So hold down 3 and then just left mouse click. We will get this node. So constant 3 vector is basically just a vector, right? A vector is 一个向量, and it contains 3 numbers, x, RGB. But just to give you a hint beforehand, it's 3 numbers that we've also seen in other places, right? For example, in this 3D world, we also have seen 3 numbers being used here. For example, in the transform tag, we also have 3 numbers, right? Here it stands for X, Y, and Z. So sometimes we actually can use the same 3 numbers, the same vector containing 3 numbers to indicate spatial coordinates like X, Y, and Z. But we'll see how that can be useful later. But just understand that a color is made of 3 numbers, so does the X, Y, Z coordinates. So now with this here, we can see that it has 4 pins. The first one is the composite color, meaning it's RGB together. We can also just output individual values from the red and green and blue channels individually. And if we double click on this black area, we have this color wheel that lets us choose our desired color, very conveniently. Okay, so if I just choose any of this color, like an orange color, and then I plug this, connect this top pin into the base color, we get this very simple orange color material. So let's before we do anything more complicated, let's just save this material and go back to our level, and let's see how we can apply this very simple basic material to our objects, which is very easy. So we select this cube that we had here. We scroll down to its material slot so that it's visible on the screen. And here, right, material and then element 0. We open our content drawer. Maybe it's too big. And we just drag and drop our material onto this material slot of this model here. Right, make sure it's visible on the screen. And then just drag and drop it here. You can of course also use this drop down menu. If you remember the name, like m_test, you can also just search its name and select it. And now we have a very simple but nice orange cube here. Okay, so now let's go back to our material editing graph, and let's do more things to it. So let's go over most of the other properties here. So we have metallic. Metallic basically controls whether something is made of metal or not, and things are usually in reality or in the physical world, things are either made of metal or it's non-metal. So by that we can simply control it with a float between 0 and 1. So we can create a one number constant node, and the shortcuts for that is just holding down 1 and then left click. Then we get a simple sort of constant node with just one value. We can connect this with the metallic. And we could now change the value of this metallic node. If we put, for example, a 0, you can see how it updates on the left, which is the default value that the metallic node has. It's a 0, meaning this thing is not made of metal. So it kind of has this plastic kind of look. If we change it to 1, notice how this object change. Now it has this sort of metallic or metal-like sheen, like almost make it look like a golden surface, right? Or a bronze gold surface. You notice how the reflection kind of change. Of course, you can use a value in between to make it look kind of look like something that is between metal or non-metal. But usually, we keep the value or always keep the value between 0 and 1, because a value of 2, for example, doesn't really do anything to it. It's just would have the same node, same look. So let's maybe, for example, put the value back to 0 for now, and let's look at the next property first. The next one is specular. Make sure you put the metallic value back to 0, because the next property that we'll be looking at, the specular, will only work if the metallic value is set to 0. I'll explain why. But let's also get a number, get a one constant node, holding down 1 and then left mouse click, and let's plug this into specular. So notice the preview on the left kind of change. By the way, you can also change the preview objects from a sphere to something else if you click on this tiny icons that you see on the bottom right corner of the preview screen. So with a value of 0, the specular basically control how reflective the surface is. With a value of 0, it means that it does not reflect any light, so it has a very dull surface, like not much light or no light will be reflected from this surface. It's just look like its original base color. If we give it a value of 1, notice how we now get a soft highlight, right? Some sort of a highlight, which is the reflected area that we have on the surface. So now the surface has become very, sort of like very reflective. Let me change something. Okay. And remember, this specular value only works on non-metallic materials, so it has to contain a metallic value of 0. If you change anything on the metallic, for example, if you give it a value on a metallic surface, then this specular won't have any effects anymore. You'll see that it always has the highlight. Okay, so that's the specular. Now let's look at roughness. Roughness is sort of work together with the specular or with the metallic to control the sort of the surface feeling of the material. Let's also give it a constant node, holding down 1 and then left mouse click, plug this into roughness. Now with the value, so without connecting any nodes to it, most of these pins will have a default value of 0.5, right? That's how you get this default look. If you can connect this node, which contains a value of 0 to roughness, you already see immediately that it has a very big change, big effects on its surface. So roughness with a value of 0, meaning it's completely smooth, very smooth on the surface. It's like no sort of friction at all. It's like a very sort of shiny, glossy surface, and you can see very clearly the reflectance. Sort of on the surface, like it's you can see almost like a mirror. You'll see the surrounding areas being reflected on its surface very clearly. If you increase the roughness value, you slowly, I'm basically just holding down the left mouse button, and then I can slide this value on the left sort of this deep detail panel, right? You can slide this value. When this value gets closer to 1, you see that the surface become more and more sort of like rough, and the reflection becomes sort of more and more sort of rough and vague, until you don't really see the reflected image anymore, and it just kind of has a very even surface. So with a roughness value of 1, meaning the surface is very rough, so even though it is still reflecting, but because with a very rough surface, the light is kind of like bouncing in all directions, so you don't really see a clear reflection or even the highlights of the highlighted area from the light anymore. So you just see a very flat, dull surface again. Okay, so I will maybe give you 1 or 2 minutes just to play around with these settings. For example, try different combinations of either specular and roughness or metallic and roughness, and see how different combinations affect the look of the surface. The only thing to remember here is that in order for the specular to work, metallic has to be set to 0. So you either have metallic and roughness, or you have specular and roughness. You cannot have both the metallic and the specular. Okay, so now maybe take a few minutes to play around with different settings. Okay, I believe this should be quite easy for most of you. So let's continue. So besides using these very simple controls like some 3 vectors to control the color, and then a value between 0 and 1 to control metallic, specular, or roughness, we could also bring in image textures to control these properties. So we can use 2D image to feed this value, to give value, to provide value for all of these settings. Color is easy to understand, right? So if it's almost like an image that I put on the surface of this table, like if I glue it on the surface of the table, then it looks like it has an image being sort of applied to it. So to bring in a texture into this node graph, we can right-click and search texture, and we have a node called texture sample. Because it is also a very commonly used node to apply texture to materials, it has the shortcuts of T. So just hold down the key T for texture, and then left-click. We have the texture sample node. So the texture sample node has some similarities, right, with this color node, this vector node here. It also has these outputs like RGB, the composite color, and we also have RGB channels individually, and we also have this alpha channel that sometimes used to control other properties, like for example transparency. Later on we'll use it. But most importantly, this texture sample node will allow you to, if you look at the details panel on the left, you see that if you scroll down a little bit, it has this texture slot, which allows you to choose a 2D image and then apply to be the sort of the surface look for this material or this. So if we if we sort of scroll down a little bit, we can see there's a UE logo. We can also just maybe search for it, logo. Now we see this sort of image being used here, sort of showed up here, and we can plug the RGB pin into this base color input. If you don't see your node or your material being updated in the 3D world, what you need to do is just click on apply on this menu up here. Then it will update the material. And we can also sort of choose some other material that you can try. For example, we can use the wood. So choose any of the wood color. Make sure the one that you use ends with the letter D for sort of a diffuse color. So this is also a word that you might often see later on, diffuse. So when you see the word diffuse being used in the texture, it usually means that it's being used to control the base color of the material. So you can search, for example, wood here, or you can, for example, search brick, and then choose this texture that ends with the letter D to just try a few to see how it affects the look of the surface. Okay, so now let's unplug this texture sample, holding down Alt or Alt on your keyboard, and then just click on one of the connections. It will disconnect, and then let's plug this basic color back in. Change the value to sort of like a gray color. And let's try something else. So let's bring in a new texture sample. So we will now use a texture to control the metallic and roughness of this surface material as well. So in order to see that effects more clearly, let's sort of make the color to the simple gray color, and then bring a new texture sample node, holding down T and then left mouse click. We have this, and on the texture slot, click on the drop down menu and search for noise. And then you should be able to see this texture called Perlin noise, which is one of the most commonly used noise pattern. And actually, let's take a look at this noise pattern. It's just a 2D image that we can view, and to navigate to the assets where this asset is located, you may use this icon or this button here, and you can use this button very often when you are working with Unreal Engine. When you click on it, it will open the content folder and it will show you where this assets is located in the folder. So you can see that it will pop up and show you that it's inside the starter content and then texture folder. You'll be able to see this Perlin noise. If you double click it, it will show this image window, and you can view all the properties here. So later on, maybe we'll also do something here in this image window. So as you can see, this is just sort of a random looking noise pattern. Now let's go back to our material editor. And because this pattern looks exactly the same on RGB or either R, like red channel or green channel or blue channel, it all looks exactly the same. So then we can, when we are using the output pin, we can choose either one, or we can choose the RGB pin. It doesn't really make a difference. If we plug this output into our metallic, we will see now the surface has a very different look. So in this kind of a simple black and white texture, it's oftentimes means you can use the black area as the value of 0, and then the white area as a value of 1, and all the gray area will be a value in between 0 and 1. So that's how you can use a 2D image like this as a texture to control the other properties in the material editor. Let's see here, something is, yeah. You can do the same thing to specular or roughness For example, now let's maybe try the roughness part. I think the effects will be more visible. So let's disconnect this texture sample and make this metallic being controlled by a value of 1, so that it's meaning it's a metallic plate, a metallic surface. So it looks like a piece of metal. And then let's plug this texture sample into roughness. Yeah, I think this effect actually is more visible. Now you can very clearly see, if you rotate your camera, you can see that the white area on the texture, meaning it has a value of 1, meaning the white area is completely rough, and then the black area would have a value of 0. When it's being used on the roughness, it means that it's a very smooth part. So you can see that the surface now looks like it's being sort of frozen to different degrees on the surface. So some parts are rough, and then some parts are reflective. This also looks like kind of a rusty metal. Okay, so now we understand how to use either a number or a texture to control some of these properties. But the one of the issues we have when using a texture, for example, to control the roughness, is that it's not very flexible, right? Because say if we look at this material and we feel like we want the most reflective part or the smoothest part, right now it's completely smooth, right? But what if I want it to be less smooth? I want it to be sort of like, not so different from the other area. For example, right now you can see that this area, this part, is completely smooth, right? This spot, it's almost like a mirror, and then some other parts are completely rough. So the contrast is very strong. What if I want to change, some of these so that it doesn't look so dramatic, or it doesn't look so contrasty. But the image, the 2D image, is already fixed. So like if we need to do that, like we feel like maybe we need to edit the original 2D texture, like in Photoshop, to make it less contrast. So that would be a very sort of time consuming, right? So we could here simply use another node to control control the transition between the black and white value. And this is actually a node with the same name that we have used before in the Blueprint editor. It's called the lerp node, which stands for linear interpolation. So we can search lerp, and it will show linear interpolate. So right click, search for lerp, LERP. The first one, the highlighted one, linear interpolate, would be the node that we want to use. Yeah, so this looks very similar to the same, the lerp node in Blueprint editor. So we have two inputs, value A and B, and we have the alpha value. And so here we could, for example, plug this texture sample node, the output of the texture sample, into the alpha, and then connect the output pin from the lerp node into roughness. Okay, so what this does is that now you're still using the same texture, but now you can manually control how rough or how smooth the area is by changing the minimum value and the maximum value, right? For example, if I increase the minimum value to something like 0.2, you'll see that previously those very smooth area now becomes less smooth. If I keep increasing it, 0.4 for example, yeah, you can see the effects better. Now all those very like highly reflective, like very smooth parts are now becoming more sort of have a duller look, like a rougher look, right? So because what a lerp node does is that it takes the value from the input texture, it remap it caps the minimum and maximum value between the two numbers that you provide, right? So you can say use this texture, but I want the least rough spot to have a value of 0.4, and then the most rough spot I wanted to have a value of 0.8. So it's not completely rough. It still is kind of has some. So you can, by this way you can limit, or you can change the contrast. If you give it a value of like between 0.4 and 0.5, now the change is very subtle now, right? So the lerp node is very useful and also very commonly used in the node editor. So it actually also has the shortcuts. So if you hold down L for the first letter L and left mouse click, you have the lerp node here. Okay, so now let's continue with this main list that we have, and let's talk about something else. Emissive color, it's less common when we use material, because most things that we can see, except for the lights, most things in our daily lives, they will not emit light by itself, right? But when we do need that, for example, if we are making a light with shape, like for example the emergency exit sign, or for example like the computer screen here, we could use the emissive color. So let's bring in a new let's try using color first. So let's hold down 3 to get the 3 vector, and then plug that into emissive color, and then we change the color to maybe a red color. You can see that this emissive color, the effects is very strong and almost completely override. So for example, if I change the base color to blue, so even though it had a blue color on its surface, but if I plug this red color into emissive, you can see that the emissive color, it has a very strong sort of power, right? It controls, it almost overrides the surface color. Oh, really?
It's very tiny.
Okay.
It was big before.
Okay. Cool. Yeah, so emissive color, and then we plug this 3 vector into it. You see that it becomes sort of almost overrides the original surface color. Let's apply and see how it looks like in our 3D world. If I rotate my sun, I mean the sun in the 3D space, so that I make it a dark environment, you can see that most other things are now pretty dark, in the shadow. But this cube that we had this emissive color on it still looks very bright. And if you place it next to some other objects, you can even see it create this red like light, it casts this red light onto the surrounding objects. But by using color, you could only, get this far, right? Because the most red or the strongest red you can get is here already. So, what if we want to increase its brightness, right? We want to make it like a really strong light, emit very strong red light. What we could do now, with some very simple math, is we can multiply this output from the color pin, and we multiplied it, and then use that output value as our color. So let's we can right click and search for multiply, or we can also just hold down M and then left mouse click, then we get the multiply node. And we could now, for example, connect the red color to value A, and we connect the output from the multiplied into emissive. So now we are multiplying the color red by the value of 1, right? So it stays the same. If I increase the value B to, for example, 10, now we get a much stronger emission. If we go back, we can see that the red light is much stronger now. You can keep increasing this color, this value. For example, 100. It looks like it's a really hot, glowing red. So I give you a few minutes to test this simple operation. Make sure you understand how to use both the lerp node and the multiply node. Okay, so let's move on. So we still have a few other settings, and this anisotropy, we let's skip this one for now. It's a little bit advanced and more sort of complex to explain, and also it's not so commonly used, at least when we first begin. Let's skip that and go to normal. Now we will be sort of explaining an important concepts when we apply materials. So for that, please take a look at the screen. So normal in Chinese it's 法线. It's not it's not 正常, it's not 示范, right? It's 法线 in the 3D world. So normal map in Chinese, sometimes you find texture that's called a 法线贴图. That means normal map. And normal map is a type of image that oftentimes looks like this. So you have this strange purplish look to it. And what it does is that, for example, if we have a flat surface, and we maybe have this brick texture applied to it. The texture, this 2D image, only controls the surface color of the 3D model, right? So it looks like a brick wall. But if we zoom in, we can see that it doesn't have any sort of surface details, right? It's completely flat. so it looks kind of fake. It looks just like a wallpaper being glued onto the surface. But if we want to really 3D model a brick wall, it takes a lot of small details, right? The 3D model will be very large in size because it needs to contain a lot of surface detail, like because the brick wall is very rough, so sometimes it's it's protruding, sometimes it's has different angles, right? So if we model a brick wall with like an actual 3D model, it will cost a lot of computing sort of processing power. So instead, we actually use they develop this 2D image that can provide a fake an illusion, give us the illusion that looks like the surface has a lot more detail than it actually has. And the way they do it is that we can see that the normal map has this sort of like a color wheel from red to green, and then like purple, all of these. So it's actually we're not actually using its value as color. So remember previously I said, if it's a vector containing 3 numbers, it could either mean a color, or it could mean a spatial coordinates, right, or a direction. So you all understand vector. If it has three numbers, then it can mean that it's pointing to certain directions in X, Y, or Z. So this is how the normal map works. Is that it takes the 3 number, so it looks like it's color, but it's actually providing spatial information, telling the software, where this surface is pointing towards. So originally, this might just be a flat surface, but if we apply this normal map to it, it will basically tell the computer, okay, so this face is facing this direction, and then this face is facing this direction, and it has different heights, right? So it actually provides this illusion as if the surface has been modeled and contain more details, right? So we can actually look at this. So originally, this plate might just be a very flat surface, but if we give it a normal map that looks like this, it will create the illusion that it has some, surface detail. So let's try this. Well, you won't be able to find this normal map that I will be using because I downloaded it. But you can, if you have the starter content folder, you will find a few normal map there, or you could very easily go to Google or any other search engine that you use and search for normal map. You will be able to find quite many normal maps, and also the ones that I will be using to demonstrate its effect. Yeah, you can you can do an image search of normal map, and you find all kinds of them. You can download a few to try, or you can just use the ones provided in the starter content. If you choose to download some normal map, now I will show all of you the process of importing textures into Unreal Engine, which is super easy to do. It just maybe in the material folder, right click, create a new folder, and then name it textures. And you can simply drag and drop these images into this folder, or you can click on here import, and then choose the image that you downloaded. And now I will create a new texture sample node, and then I will put one of the normal map that I imported here. and I can connect this with the normal. So now you can see its effect very visible. So even though when you look at it from the side, we can understand that it's merely just an illusion, right? Right now it's still a flat surface, but if we look at it from the front, it almost feels like it has some of this area, you know, like sticking out, or you know, going into the depth, like it has this illusion of depth or height when we look at it from the front. So when working with normal map, I keep using this example because it gives us a more sort of a visible result. So please take a look at my screen. When working with normal map, there might be a few problems that we would encounter. So if you, for example, if you see any errors when you change this to normal, make sure on your texture sample node, make sure that under the texture slot, you see the sample type. Make sure this one has been changed to normal. Unreal Engine 5 should automatically change that for you if it recognizes that this is a normal map. Because if you compare this one with this previously, the brick, you can see that when we're using the brick texture, this sampler type here is color, meaning it's sampling the color information. If we give it a normal map, it should automatically change the sampler type to normal, meaning it's sampling the directional information. If it doesn't change automatically, make sure you switch it to normal here. And another issue that we also often encounter is that let's see if it's an issue here. One moment, let me check whether it has this issue. Okay. Okay, so sometimes when you use a normal map, if it doesn't give you the desired results, for example, the correct sort of shadowing or the correct direction shouldn't look like this. So actually a different normal map, there are two types of a normal map. It's kind of confusing at the beginning, especially if you work with Unity before. So Unity actually use a different format. The main difference is that one of the axis is facing another direction. So it's a kind of abstract, but no worries if you really don't really understand it. What we need to fix it is just one click. So if we open the maybe it doesn't have, maybe your normal map doesn't have this issue, but you can try it and see if it looks sort of correct or not. But here the effect would be very obvious. So maybe you look at my screen. So notice how this square look right now. And if you find your normal map and double click it, and you open this advanced tag, sorry, actually the yeah, under the texture panel, under the texture tag, if you expand it, and you see an advanced tag. If you expand this advanced tag, you can see that there's an option, a checkbox called flip green channel, meaning turn the green channel to another direction. If you don't see it, you can just search flip green channel. You'll see that this option here, flip green channel, if you click it, you'll see that originally the green is facing upwards. If you check this one, the green now is facing downwards. This is the correct direction that Unreal Engine interpret normal map. So now if we come back and look at our material, you can see that now we are getting the correct look. So these square parts should look like it's protruding, right? Instead of going inwards. So if sometimes the normal map that you're using doesn't give you the correct result, for example, the shadow should be on the bottom part, right? So the bottom part, because the sun is on top, so the shadow should be on the bottom area. If you see that the shadow is like above, like previously, like the shadow is on the upper part, then clearly it's wrong in this circumstance. Then you would double click to open your normal map, and then find this setting under texture, and then advanced, and then flip green channel. Then it would fix this problem. Yeah, so this may sound a little complex at the beginning, but you'll get used to it. There's just only two types of normal map. One is facing a different direction from the other. So just you can look at its results and compare and see which one looks correct. Okay, so that's the normal map. Now, again, just like any other image texture, we should be able to control how strong the effect is, right? Because the image is fixed. We cannot edit the image anymore. But we can use a node, in this case, called flatten normal. So let's right click and search flat, and we should be able to see flatten normal node. And with this, we can control how strong this normal map has, in terms of its effect. So let's connect the RGB output into this normal pin, and then connect the output from this flatten normal node into the normal pin on our main material node, like that. Sorry, let me organize my nodes a little bit. Yeah, so it should look like this. You have the texture sample with your normal map, and you find this flatten normal function, and you connect them together like this. So now you can use simply use a number, hold down 1, and then plug this into the flatness. So now with this, you can control with this number, how strong it has, like how strong of an effect it has. So with a value of 1, meaning the normal is completely flat, so it would go back to its most like the flattest state, meaning the normal map really doesn't have any effects. With a value of 0, meaning that it will have the strongest effect. You can make it even stronger by going into the negative direction. So if you give it, for example, -1, it will actually enhance this normal map effects. Sometimes some people would like to use depending on if they want to enhance the effect or not, sometimes they would like to place like a 1- node to it to flip the direction, but it's not necessary, so I don't use it here to create any more confusion. But if you understand what it does, you can, depending on your programming habits, you can use a 1- node so that it change this number to a different direction. So some people like to do that. Because with a 1- node, then the value of 0 makes it completely flat, and then the larger the number, the stronger the effect. So it feels like it's easier to control. So some people like to do that. So you can also do this. So by inserting a 1- node between your number and this flatness. Okay, I give you maybe 1 minute to recreate this part. Yeah, to find the 1- node, just right click and then search 1-. You will find it. If you have any questions, please raise your hand. Don't be shy, so we can answer your question. Right, so this is the effects of ambient occlusion. Basically, it enhance the visual effects that when two surfaces are close to each other, they would both appear to be darker. So it's a technique to imitate this sort of results in more realistically. By saving a little bit of computing power, so we don't need to calculate the light bouncing so many times, right? So then we can take this information. Let's look at another example. For example, like on the left is without ambient occlusion effect, on the right is with. So you can see how these corners where many surfaces are next to each other, these areas appear to be much darker. Yeah. So to put those information onto a 2D, texture map, it would oftentimes look like this. So on the left, again, without ambient occlusion, and then this one with. So you see how, this areas where it has the wrinkles appear to be much darker, right? So, and then if we unfold this surface onto a 2D, to turn it into a 2D image, it would look like this, where the parts with the more details or this wrinkles would appear to be darker. So this is ambient occlusion. So now we understand its function, but inside Unreal Engine, inside the content browser, the starter content, this map that we will be using is actually mixed together with another map. So let me show you first. So holding down T and then left click, we have the texture sample. And with the texture sample, if you are using one of this brick wall texture, you'll see that we have brick, clay, new. So we have the diffuse map, which control its color, right? And we have the normal map, which we've been using to control the surface detail. And it also has this map, brick, clay, new _M. M actually doesn't stand for metal here, but it's actually I think it stands for like mix. Let's use this one. It has this very strange color. But remember, each color, each of these 2D image has remember I mentioned it has 3 or 4 channels, right? It has red, green, and blue, and also alpha. In the case, like for example, ambient occlusion, which is just a black and white map, right? It doesn't need red and green and blue. It's just a grayscale map, so it only needs 1 channel. So sometimes when you're working, for example, for game companies, sometimes you want to, save, hard drive space, or you want to save, memory space, right? You want to optimize your game. So one way to do that is combine multiple grayscale map into one single image. So you can, for example, use the red channel for one map, and then use the green channel for one map, use the blue channel for another map, for example. So right now, if you open this map and you just look at its red channel, you can see that this one is actually the roughness map. If you turn on the green channel, you can see that this one is the ambient occlusion map. So this is a smart technique, a little bit advanced, but I just show you, if you see a map that has some strange color, doesn't look like anything that we would normally use, you can probably guess it's being separated into multiple channels. So each channel is controlling a different effect. So let's see how we can use this one, for example. Actually, it's very easy, because previously we just understand that the red channel is controlling the roughness. So I simply plug this red channel pin into the roughness input. Now you can see that it shows a lot more sort of surface detail. Like we can see how we can get the feeling that some parts are rough, some parts are more smooth. And we can plug this green channel, connect this green channel to ambient occlusion. Now we see that the sort of this gaps between the bricks appear to be more sort of obvious. Yeah. Again, to find this map, you need to use one of this either the brick texture. So you need to find this brick texture, like search for brick in your texture sample node. Search for brick. It should give you a multiple set of brick textures, right? Like brick, clay, bevel, and then it contains diffuse, normal, and then this mix map. And then you can use brick, clay, new, and then it also has diffuse, mix, and normal. Yeah, so each type of brick texture set contains 3 different maps. Okay, so these are all the effects, all the properties that I will introduce before we take the break. Okay, so let's maybe take a 15-minute break and come back at 7:40. So a little bit longer break for you to, maybe go to the restroom and also digest some of the concepts. Meanwhile, if you stay here and work, if you have any questions, especially regarding the last part, how you find this mix texture, just raise your hand and I or Jiwon will come and help you. Okay, let's come back at 7:40. So let's first also introduce some new concepts first, which is important in terms of when working with materials and texturing, which is the UV coordinate. Okay, so you'll hear these words a lot, UV, when you're working with materials or textures. So UV is basically just think of U and V as the coordinates, like X and Y. They just use two different letters to differentiate between X and Y. So I understand like U and V as the two coordinates, two axes of a 2D image. And how when we first created all of these nodes without asking the question, right? Like how the computer or the software knows how to put this material onto an object. I mean, right now we are just using a simple cube, but what if it's a more complex 3D model? So that's the process that's called a UV projection or UV mapping. So let's take a look at this. Right. So we basically when we're little kids, when we're children, when we're young, we make this handcrafting projects, right? Where we cut these papers and then fold them into like a cube. So UV projection or UV unwrapping or UV mapping, basically it's the same idea. So you take a 3D model and then you cut it and then you unfold all of the surface onto a 2D surface to make it like lay on a flat surface, so that you can use an image, a 2D image, to control all the surface information, right? And with the mapping, the software will know, this parts of the image correspond to this parts of the cube, and then this parts correspond to this parts of the cube, for example. So this is how a UV map works. So for a more complex model, for example, a face, you oftentimes see this, right? So you have the face, and then you basically, take the surface and then flatten it to turn it into a 2D image. Then it would look like this. So it basically, this part corresponds to the ear, and then so the color for the air will appear on this parts of the 2D image, right? And you also have, for example, like a whole body kind of a 3D UV map. So you would have a 2D image like this, and then it contains all the surface information for this person, this 3D character, right? So hands, the clothing, the face. To edit or to, take the 3D model and then unwrap its surface, all of the surface onto this 2D map. If we do it by hand, it's a very sort of a little bit tricky and difficult, time-consuming process. So some 3D software, for example, like Blender, offers automatic UV unwrapping for us. This is not a 3D class, so if you have 3D, skills before, or you've taken other 3D classes, maybe you know about this process. If not, and you want to do this, you want to know how this works, you can easily find tutorial, because it's a very commonly used process. It's just very a little bit time consuming, a little bit complex. So we won't be talking about this here, but just so you understand, this is when we talk about UV mapping, this is the process of turning the surface of a whole 3D model onto a 2D image, so we can use an image to control the look, the surface look for this model. Now with this information, with this UV map, then we can actually do something else in the game, in the engine, right, in the 3D world. So for example, here we have in the texture sample node, notice that we have an input pin that's called UV, right? So we actually can connect another node to here, which is called texture coordinate. So we search texture and then texture and then coordinate, or we just search for coordinate, maybe it's easier, COOR, and then the first one appeared will be the texture coordinate node. So this is a simple node, but it has this on the bottom. You can actually expand it to have more inputs, or you can go look at the detail panel on the left. It shows the same controls. So it basically feeds the UV information into the texture sample. So we connect it this way. Now we can, it takes the UV information, and then we can actually manipulate it with this texture coordinate node. So for example, we can control the tiling of the UV of the texture. So what that means is, for example, the brick wall, right? Originally, it's like this. So this is exactly how the image looks like. So this is exactly the same size as the image. So when you create an image, if it's this big, it's showing 6 pieces of bricks on the first row. Then the final results you get here, you will see 6 pieces of brick on the first row. But with this tiling, we can actually control. We can actually, so imagine, so this is an image, and then I can shrink it down, or I can make it larger to cover a larger area. And when I shrink it down, it actually repeat the same pattern next to each other. So we get a repeating kind of effect. So we can try this. So if I type 10 on both the U tiling and V tiling, make sure this also goes actually into the normal map, because otherwise it looks very confusing. So make sure this texture coordinate output pin also connects to the input for the normal map, and also for this basically all the texture map, texture sample node that's using controlling the brick surface. Otherwise it's a little bit confusing to see the effect. Okay, so maybe let me decrease the number. So instead of 10, maybe I type 2, so that it's easier to see. So when I type 2, you notice that the brick wall has been repeated twice in both the U direction and V direction, right? So now instead of only 6 pieces of brick, now there are 12 pieces on the first row. So basically, you can think of it as that this pattern, this same 2D image, has been repeated 4 times. So 1, 2, 3, 4 here. So you can keep increasing this value, like maybe 3, then you will get a sort of an effect with way more bricks. On the other hand, if you type in a number smaller than 1, you will actually enlarge the image so that only parts of it is covering the 3D model. So for example, if I type 0.5 on both U and V, you'll see that now I get this effect where the bricks becomes larger, but we only get 3 pieces on the first row. So because the image has been enlarged, so only 3 pieces can be shown on this model. Yeah, just take a minute or two to look at this effects. Try this effects. Try different kind of a tiling size. Stop recording. So let's talk about a new concept in Unreal Engine. Now we can close this material editing window for a short moment, and let's go back to our content browser where we created our materials. So now, so far, we have only one material, right? We did everything here. Let me clean it up a little bit. So I delete all the unused node. See. So let me delete all the unused node. Also remember with the lerp node that we introduced previously, right? So you can insert a lerp node here to control the for example, the roughness. So to sort of limit or enhance the roughness effects or the ambient occlusion effects. So previously we have a lerp node. Let's see, for example, if I want to control the roughness, I just insert a lerp node and then plug the output from the texture into the alpha. Then we can use these two values, A and B, to sort of control the minimum and maximum roughness. So this is what we have been we've talked about before. Now I just deleted all the unused nodes to clean up my my node graph a little bit. And let me go back to the content browser. So we have this material. It's here. So imagine if you have multiple walls and each of them has a different texture, right? Because not all the walls, two walls should look quite different, right? Maybe you have one wall that is new and then another wall that has a different color, for example. In that case, if we don't understand how the engine works, maybe the tendency is to duplicate, or copy and paste multiple of this material node and then double click, open it, and then maybe change the texture here, right, to a new texture, so that we get a different wall. But actually, this way costs both a lot of time and it's difficult to edit, and also each of these material nodes actually consume its own sort of set of computing resources. So with many nodes like this material nodes, it's actually very heavy on your project. So one way to optimize this is that we create material instances. So instead of using this original material node, we create instances. And what instance does is that think of it as like children of this parent node. So they inherit all the basic properties that you give its parent. So it will have all of these settings, but it's just like simplified copies. Basically, you can think of them. So it won't let you edit these nodes anymore, but you can still change the settings on each node. So if you want to change the nodes, you still need to go back to this master node, this parent node. But if you have all the necessary nodes created already, and you simply want to change the settings, for example, maybe you want to change the texture, maybe use a different wall, or you want to change, for example, the roughness. So maybe one wall is very smooth, the other one is very rough. If you just want to change basic settings like this, is much easier to do on the material instance. So to do that, let's right click on our master material node in your assets browser. You'll see there's an option called create material instance. Okay. So usually the naming format, we can call it MI for material instance and then underscore test. So when you see MI, you know that it's a material instance, and actually it also says it at the bottom. So you want to keep both has the same name, so mtest and MI test. So you know that MI test is an instance of m underscore test. So now if I save this and I double click and open this, you'll see that this time we don't have the material graph, no graph anymore. We just see a large preview of this material. And on the right side, we have a larger detail panel with very few settings. So we currently don't have much settings here. Actually, we cannot actually control anything on this instance right now. That's because we need to do something else to the parent node, to the parent material. So you can see that this is just a simplified copy of this material. So it looks exactly the same, except it doesn't have the no graph. We cannot edit anything. We cannot change anything now. So let's go back to our parent material, to our master material, and let's do a few things which will allow us to edit this material instance. So let's, for example, right click on this texture sample node, right click, and you'll see there's an option called convert to parameter. It's the third one down the list, convert to parameter. Once you do that, it asks you to rename it. Let's rename it, for example, color, because this one goes into the base color input of our material. Or maybe the better name would be diffuse color, DIFFUSE, or you can call it base color, depending on which one you remember, because there are other colors, right? So either diffuse color or base color, because it goes into the base color input. Let's also do that to our, for example, let's do that to all the other texture sample node. So right click, convert to parameter, and then rename this one normal map, because it's taking a normal map. Right click on this one, convert to parameter. I think this one is controlling both the roughness and ambient occlusion, right? So this one would be roughness and AO. So AO stands for ambient occlusion. So roughness and then dash AO. So we know it's roughness and ambient occlusion. So now what this does, let's see its effects first before we change anything else. Let's apply. Let's go back to our 3D space. Let me make the sun goes up so we see this cube more clearly. So this is our cube. Currently it has the master material on, right? Let's change that. Let's apply our MI underscore test to it so that it has the material instance instead of the master material. So apply the mi underscore test to its material. So it looks exactly the same right now, but let's make a copy holding down Alt and then just drag this transform axis to move it. So when you hold down Alt and you move it, it will create a copy of this object, right? We talked about this before. And now let's open our content browser and we duplicate this mi underscore test instance. So we duplicate the instance, right click and then duplicate. So now it's mi underscore test2 maybe. So we now have two material instances. Let's give the second cube the test2, mi underscore test2. Let's give it this one. So now we have two cubes. The first one has mi underscore test. The other one has mi underscore test2. Okay, and they should look exactly the same, and they both should be a material instance, not material, right? So now let's maybe double click to open mi underscore test2 or either one. Now we can see on the right side on the detail panel, now the 3 texture sampler node that we have converted to parameters, now they all show up here. Okay, so this is very powerful, very useful, right? So now we can actually, just check, turn them on. Just check the checkbox at the front. Now we can actually change all of these textures to a new texture map. So for example, instead of brick clay new, I can use brick clay bevel D, and I change all of these. So both the normal map and this roughness and ambient occlusion, change them to the matching ones. So now, as you can see, I completely change this material instance to a completely different wall, right? So compared to the first one, so this is test2, this is test. You can see just by a few clicks, I change it into a completely different wall. If you go back to our 3D world, you see now this cube looks completely different from the first one. And we can change this, without opening this node graph, because the node graph is it can get very complex later on when we have more and more functionalities. So every time if you need to change something, you need to open this and find a node and edit it. Can get more and more difficult. And also, as I mentioned, this material, it costs more computing resources, so it's heavier on your project. Versus instances, they are much more, efficient. They are smaller. They are easier to edit. So remember this. In the future, in your project, all the models should only contains material instance, not material. So the good habit always is that you create a material and never apply the master material to any objects in your 3D world, but instead create instances of it and then apply the instance to the 3D objects. And this also is the same if you are downloading some assets from, for example, the marketplace. You will notice that they have, if you download, for example, like a set of materials, you'll see that they will have a master material, like M underscore something, and then they will also have a whole bunch of material instances that looks completely different. or slightly different sometimes. So you always want to use the material instance rather than the master material. Okay. So now, with this understanding, I give you 2 minutes to finish. So you will have two cubes. Each one has a different material instance, and then change the texture that you use on one of them. Okay, if you haven't finished, you can maybe pause for now. Let me talk about the next thing so that you can do it all together. The theory or the principle is the same. So what we want to do is, for example, we want to convert all of these other values into also parameters. So for example, the thing that we want to do, let's say we want to remember we have this flatten normal node, right? And then we have this value controlling the strength of the normal, right? So we have this number. So we can also do the same thing to this number. Remember, so let's find it, right? Flatten normal, and then we have the 1 minus, and then we have this node here, which right now is just a constant. So let's right click also, and then choose convert to parameter. So now we give it a name, normal strength, because it's controlling the effect or the strength of the normal map, right? So now we have turned this, originally it's just a fixed number, now we turn it into a parameter. And there are some changes to the detail panels on the left, but let's we can ignore it for now. Let's go to our material instances. Now you can see that this parameter now also shows up in your in your material instance. Now we see there's a control for normal strength. If we enable this, now I can simply slide this number, and you can see that I can control, how strong the normal map appear. So as you can see, this becomes very convenient, very useful to do. And notice that when you edit one of the material instance, it does not affect the other one. It also, of course, does not affect the master material, right? So you can have many versions of the same material being applied to different objects, and you can control their properties individually. So let's do the same thing for some other parts. For example, if I want to control the tiling of the texture coordinate, so previously we have the texture coordinate, and then we multiply it by a value, and then we connect that to the UV inputs of the texture maps, right? So now, instead of manually typing this fixed value, let's now make this into also a parameter. So first, let's hold down 1 to give it a one vector node plug that into the value b here on the multiply node. So we multiply the textual coordinates with another number. And on this number, we can now right click and then convert to parameter. Now I can name it texture tiling, T-I-L-I-N-G, texture tiling. The default value would be 1 because we want to repeat it only once. Okay, now with this, let's click on apply to apply all the changes. Now if we go to our material instances, we can now see this texture tiling control show up here. If we enable it and slide it, we can now see that I can very easily control the pattern, the repeating patterns on the material instance. So many of these nodes can be turned into parameters. So the following maybe 5 minutes, please do this. So convert as many nodes as you can into parameters. So for example, this lerp node, you have value a and b, right? So plug in 2 numbers to value a and b, and then convert those numbers into parameters so that you can control them on the material instance. And then also, these 2 numbers that is currently controlling metallic and specular, you can also turn them into parameters so that you can later change them in the material instance. So take 5 minutes to do this on your own. So for example, this one, right now it's controlling the specular. I will right click, convert to parameter, and I will type specular. Okay. So this one, please pay attention. I forgot to mention. So some of them we don't need to change anything because their value is just can be infinite, right? Sometimes you want to limit the value, like how much it can be changed, maybe within a certain range, because as we have understood, specular value only range between 0 and 1. So you want to limit this parameter to only has a value between 0 and 1. So you can do that here on the left on the detail panel. You can see that there's an option that lets you change slider min and slider max, right? So the min could be 0 and max could be 1. So now when someone, for example yourself or maybe another person in your team comes and edit this parameter on your material instance, now this specular value, they can only edit it between 0 and 1. They cannot go above 1, right? So this is also a very useful thing to do to limit the range of these parameter values. So now take 5 minutes, convert some of these stuff, into parameters. Remember, every time you change something in the node graph, you need to apply it before you can see it appear in the material instance.
material instance. Why?
Okay.
Just
Okay.
the concept of it from like a parent-child and changing the parent and affecting all the instances.
Okay. Cool.
It's a little theoretical.
Okay, I will do that. Yeah, okay, so I think maybe some of you are still not very sure about this whole material versus material instance concept. So let me explain briefly again. So you have this one master material which contains all the nodes, all the scripting, all the functionalities here that you created. And then you can create as many instances of this same material as you want. So you can have just one instance, or you can have 100 instances. They will all inherit all of these properties that you give it, and including all the same parameters. So now we have two instances. They all have the same set of parameters that we can edit. So think of this master material as the parents, and then all of these as the children, right? So they are brothers and sisters. So they all have the same, DNA of the parent material, but they can all look slightly different, right? And you change something on the instance, it will not affect its brothers and sisters, right? So if I change this to look like this wall to look like this, but the other instance can look like this. So changing one does not affect the other. But if you change the parents, then you actually change the DNA, right? Then the whole other material will change. Because, for example, now you say, oh, I don't want to have a texture to control the surface anymore. I just want to use the same simple color. So if you create a color node and then feed that into base color, then all of the instances will change together. They will all be using color instead of a texture. So if you change something in the parents, it will affect all the instances. But if you change one instance, it will stay that way. So in this way, it's very easy, and it becomes much easier for us to say, okay, I want 10 different walls. Each of them looks a little bit different because they have a different color, different roughness, but they all have the same functionality because they all need normal map, they all need a roughness map, they all need a base color map. So you would create one master material and then create 10 instances and then apply those instances to the 10 different walls. This way, it's not only easier to edit because you can just open one of the instance and you see all the settings here. You don't need to open this master material and then find where is the node that control, for example, the roughness, the max roughness, right? If your node graph is very complex, you need to look for it like this, and then it gets very confusing. Versus you just open an instance and then all the settings, all the important settings are listed here, and it's very, very easy to control. And also the material instance is much lighter, much efficient for the software to use. So it actually save your memory, save your disk space, for example. So so remember in the future, always create material instance and then apply those to your 3D models. Okay, so that's I explained this why we use material instance again. Now let's see. So as we create more and more parameters, we can see that the list keep growing, right? So there are more things we can edit. Now let's introduce a little bit how we organize these settings, because it gets a little bit confusing, because we can see now I have a max roughness and then I have a minimal roughness, but then the metallic setting is kind of like situated in between these two, right? Because they all starts with the letter M, so it's very confusing, like max roughness and then metallic and min roughness. So it's a little bit strange. And we also have texture tiling, like this kind of unrelated settings. They all mix together. So here, if we go back to our master material, in the detail panel, we can see that if we look at the detail panel, we can see that there is this group. So if we click on each of the parameters, for example, this max roughness and min roughness, we can see that there's a group, and then there's also sort priority. So we can change the priority to make them appear higher on the list. We can also assign them to different groups. Right now we don't have any groups, so it says none. We can type in, for example, surface, then we would assign them to the surface group, and then later on the metallic and specular, we can also assign them both to the surface group, because we created a new group by typing in. And maybe I want to have the min and max roughness to have a lower priority, so maybe I give it like 33 instead of 32. So this should be easy to understand, right? You create a new group and then you assign different parameters to the same group. Now if I apply and go back to the material instance, we can see that we now have a new tag called surface, and then under this surface we have the metallic first, and then specular, and then the max and min roughness are like standing together rather than being sort of mixed together with some other unrelated settings. So this way you can organize, once your parameter grows, you can organize them this way. This is just a simple organization techniques. Okay, so let's see if we missed anything. Okay, I think that's all I want to cover for the material, in terms of the material editor today. I want to sort of maybe let's see what's the next that we need to do, so that you can because we do have a simple assignment for you to help you make progress on your project. Last time I asked you all to submit this asset list, so make sure this is to make sure that all of you spend some time browsing the assets online, and find the stuff that you want to use. And this week, after we talk about this material editor, you should already be able to download some of those models and import them into Unreal Engine, because now you understand how to use the texture file. So when you download an asset, it contains the model, and it also contains the texture maps, like in the image files, like sometimes PNG or JPEG, or some other file formats like TIFF. The TIFF is another file format. Sometimes it's a TGA, but again, you can look at all of them on your computer, and they all will show up as image files, and you can tell by their names, which image is used for what type of maps. So for example, if an image that looks like this purple color, or maybe its name has the large letter N like this, you will understand it's a normal map. If it has the large letter, capital letter D, A, B, C, D, D, then it would oftentimes be the basic color, or sometimes referred to as a diffuse color. Yeah, diffuse color is simply just what you can understand as the most basic sort of a surface color that the 3D model has. So if an image contains the capital letter D, it's oftentimes the diffuse map. So you can tell by the, in the file name, what kinds of, capital letters it has. For example, if it has a AO and it's a black and white map, it means it would be the ambient occlusion map, right? And if it has the letter R, sometimes it would mean it's a roughness. Yeah. So, and also you can see, well, if it's a metallic, or it would maybe it has the letter M and then specular, for example. Sometimes when you download a model, it will contain something called like a height map. So let's, and it would be a black and white color map. Let's ignore this for now. I will, talk about this maybe next class. So maybe it starts with the letter H, well, not start, but contain the letter H. Oftentimes it's and then it's a black and white color. It would be the height map. Sometimes the height map is used in replacement of the normal map, but it requires a different process. So yeah, and let's see what else. Yeah, and the 3D model that you would download, so I would put all of these in the assignment page, so you can look at them later. But you will see that the 3D model that you download would have, FBX, would have different file types. The most commonly used one, and the one that if we can find this format, if it contains this format, then try to import this one. Sometimes they have multiple formats for you to choose. If you find, for example, FBX, that's a very good format for us to use. If we don't have FBX, if it has OBJ, that is also fine, and it's also very common. .obj file. Actually, I think there is a list. Common 3D file type. And then if you see the word STL, usually these models are used for 3D printing. They don't contain any surface information like material or texture, so it's just a simple basic model. So it's not so good for our project purpose. But if you find a very good model that only has STL, then you have to use it. Yeah, so these are probably some of the most common ones that you can find. Also, we would sometimes have a Collada, which is DAE. If you download models, for example, from SketchUp, maybe some of you use SketchUp, it's oftentimes in this .dae file. Sometimes the engine doesn't use it that well. It needs to be better converted, better use it. If you want to use it, it's better to convert it into like OBJ or FBX. But that require you to have some like 3D skills. And if you see any other file formats, like for example 3ds or .max, right, or like .ma or .mb or C4D, of course, or .blend, these are like specific file types associated with other 3D programs like 3ds Max or Maya or Cinema 4D or Blender. In this case, unless you have this software on your computer and you know how to convert these file formats, you won't be able to directly import them. So it's always better to find models that are in either FBX or OBJ, unless you have some basic 3D skills. You know how to convert from these files into like FBX. But of course, these are very easy to find, like tutorials online, like how to convert C4D file to FBX. So I don't need to really provide these information because it's very easy to simply find them online. You would just install Cinema 4D or any other software. Like if it's Maya, then you would need to install it and then convert it like this. Sometimes you would be able to find online converters. You can try those, but there aren't anyone that I really specifically recommend. Okay, so that's actually all the contents for today, and then look out for the assignment page that I will have. So the assignment is basically for you to download some of the models and then create a new environment in Unreal and start placing those models into the Unreal Engine and create some basic lighting. So basically just try to see how a 3D model will look like once you import them into Unreal Engine, and maybe give it some basic materials just to try it out, and if your downloaded assets contains some texture map, then try to create a material that can use all of those textures. So that's the assignment for next week, and again I will write that in the assignment page in more details. Okay, so today we can maybe leave a little bit early. Unless you have any questions, then you can stay and ask. Otherwise, see you next week.